Fifth graders, today we are doing Eureka Math Module 2, Lesson 18, and we are continuing on with the same concept of what we were talking about yesterday. We're going to estimate the quotient of two-digit divisor problems, okay? When we do that, let's remind ourselves, what do we estimate, what do we round first, the divisor or the whole? Everyone?
Divisor.
Good. So, if Sandra bought 38 DVD movies for $874, how much, we want to give an estimate of how much each cost. So, if every DVD movie costs the same amount of money, we know altogether she spent $874. We have to divide that cost evenly by 38. So since you guys all know we have to round the divisor first, which number is the divisor?
38.
38. And so 38 is pretty close to?
40.
And why do we round the divisor first? Why do we? Show it. So that we can find a compatible whole that will be as close as possible to this problem, right? So if our rounded divisor is 40, what fact family are we thinking?
Fours.
Fours, right? So if I think about my fours, what is pretty close?
88.
88, right? I was thinking 84, but if I go one more, 88, that's even closer, right? So should I write 88 divided by 40?
No.
What should it be?
880.
Good. Now, some of us are not expanding out the 40. Some of us are not doing that, and it's okay because we're not making mistakes. But some of us are not expanding it out into 10 and 4, and we're making mistakes. So, is it worth it to expand it out to avoid making a mistake?
Yes.
What do I mean by that? I mean you can write 880 divided by 10, then divided by 4. Then I can think about 880 divided by 10 is?
88.
So this problem then becomes 88 divided by 4, which is?
22.
22. Good. Dollars. Good. We already know we need to round the divisor first. 23 is pretty close to?
20.
Good. So that means we're thinking about what fact family? 2. Okay, so let's take a look. We could say this is pretty close to 8,000, right? Is there anything that we could say that's closer, that's still easy to think about? 8,080, perhaps? Could we?
Yeah.
Or 8,100?
Could be.
Because if I did 8,100, do you guys agree that that's pretty close?
Yeah.
I could think about 8,000 divided by 20, which, actually, hold on. Let's
No.
expand it out, because it would be 8,000
Divided by
10 divided by 2, right? Which would then be 810 divided by 2. Now, depending on how you think about numbers, you might think, well, 81 is not compatible with 2, right? And so you might say, Miss O, I don't like this. It doesn't make sense to me. That's fine. Could you also say 810 is divisible by 2? Because I can do 800 divided by 2, which is?
405.
And then 10 divided by 2, which is 5, right? So I could think about it in two parts to make 405, okay? Or I could also take another route, and if I don't like that, I could also say, I know that 880 is close to 895. Do you guys agree? And that I can think about pretty easily divided by 20. I can do 880 divided by 10 divided by 2, which would be 808 divided by 2. And now both of those numbers are even, so then I know that's 404. Do you see how our two estimations are different, and yet they're both pretty close?
Yeah.
Right? So when you estimate, is there only one right answer?
Nope.
No. But the closer you can make your estimations to the actual numbers, the more accurate your estimate will be. Okay? So today, especially when we start working with bigger numbers, there may be different answers. Is that okay?
Yeah.
As long as you can justify or back up why your estimation is reasonable or why it makes sense, then it's fine. Okay, which number do we round first? Divisor, which is?
48.
What is, with a quiet answer here, what is a divisor that's easier to work with and think about fact families with that's close to 48? Anirudh? 50. 48 is close to 50. Which means then what fact families are we thinking about? Fives. Okay. So, think about a whole that's close to 2,691 that is compatible with 5. In this case, you're right. 3,000 could also work. 2,700 is not as good because it's not in the 5 fact family, right? they are divisible, but I don't know it in my head as fast. Why is 3,000 not as good of an offering as 2,500? Violet?
Because it isn't as close to 2,691.
Yeah, it's not as close to our original whole, so it won't be as accurate. We want to be as accurate as possible. Okay, so let's take this one. How could I expand that out? How would I expand it out, Maham?
Oh, so you would first do 2,500 divided by 10 divided by 5.
Which allows us to do 2,500 divided by 10, right? We can think like that, which is 250 divided by 5. Now, we can think of 250 as 25 somethings.
10.
We have to think about uniform, and when we do that, we look at the number and we look at the rightmost digit of that number. The 5 is the rightmost digit in 25, right? 25 is in what place value?
10.
Okay, so this is the same as 25 tens divided by 5, which then allows me to think, okay, 25 divided by 5 is 5, but I'm in the tens, which then tells me the answer is 5 tens or 50. Okay, good. This one's an interesting one because normally we want to round our divisors to be a multiple of 10. But I might argue that in this case, our divisor is 95. I may not round it to a multiple of 10. I might not move it to 90, or I might not move it to 100. I might keep it the same as 95. Why do you think that might be? When we estimate, is there only one right way to do things? No. But the closer we can be to the actual numbers, the more close our estimate will be to the actual answer. Jonah, hold on one second. There's a couple, I can think of 4 different ways we could successfully estimate the quotient here. Jonah, what's one way?
You could do 9, you could round, you can keep 95 the same and round 9,215 to 9,500.
Do you guys see how that's compatible? Okay, there's another way we could do this. Taya.
We could change 90, or we could either change 90 to 100 or 90 to 90.
Okay, pick one. Pick one. How about 95 to 90? Good.
Okay.
And then
you would do, then you would round to 9,215 to 900.
9,000.
9,000.
Good. Okay, what's another way? Ikaksh.
Similar to Taya's method, so we round 95 instead of rounding it down, we round it up
Okay.
to 100, and then 9,215 goes down to 9,000.
Oh, goes down to 9,000. That would be closer, yeah. Good. I can think of another method too. Nadav?
So instead of rounding, so if you round 95 up to 100, I think you could just keep 9,215 and then do the
Oh, you could. So Nadav is saying, because we know about shifting with place values, if I divide by 100, I could just do this.
Yeah. You don't have to round it.
And I would just shift the digits, right? What if I rounded the divisor to 92? Could I do that? What would the whole need to be compatible with that? What would the whole need to be? Sushant? Okay, so look at all these different options. When you estimate, there's not just one right answer. But you need to be able to think about what are the different options and which one is the best and why. Usually the closest will be the best, but sometimes, depending on what you're doing, you might want to overestimate, right? If I'm going to the store and I don't know exactly how much money do I need to bring, do I want to bring a little, make sure I have more than enough, or make sure I have almost enough? More than enough, right? So depending on the situation, your estimation techniques are going to be a little bit different, okay?